Yeah, I want to talk to you about processing videos using your graphics cards. First, a little bit about me. I guess Maciek already said everything, but hi, I'm Jerzy Wilczek, or you can call me George if that's easier for you to pronounce. I work here at Software Mention, and now we can get into the talk. First of all, why were we here interested in processing videos using the GPU in the first place? I work on a project called Smelter. Smelter is basically a video processing server that can take videos or live streams as inputs, then process them in some way, and then produce some output video or an output stream. And real-time processing is a very important goal for us in Smelter. We want it to work real-time. So you can see how it seems beneficial to use the GPU because it can make stuff faster, more efficient, stuff like that. And for the last 1.5 years, I've been working on using Vulkan Video in Smelter. So now, what's Vulkan Video? The name is made out of 2 words. I thought we can first take a look at each of the words separately. So first of all, what's video? You probably know what video is if you're here at this conference. It's many images in sequence, and they're heavily compressed because uncompressed video is huge, tens of gigabytes per minute of video, basically. And if you want to process a video, then you have to most likely decode it, then modify it in some way, the decoded video, and then encode it again to make it compressed so you can send it over the network or store it in some way or whatever you want. And decoding and encoding are computationally difficult, especially encoding, and consume a lot of resources and are a big bottleneck. So now what's Vulkan? Vulkan is an API for rendering things using the GPU. So it basically exposes the capabilities of your GPU in a programming language. Some of you may not have heard of Vulkan before, but probably most of you heard of OpenGL. And Vulkan is a successor to OpenGL. And a lot of the things that OpenGL did that didn't turn out to be very future-proof, Vulkan basically improves on. So a good example is that OpenGL has a lot of global state, so it's difficult to parallelize because the different threads end up overriding the global state, and it just doesn't work, and Vulkan is made with parallelization in mind, and that's one of the examples. There's a cost to those improvements, because a lot of the things that OpenGL did automatically in a way that turned out not to be very future-proof. In Vulkan, the responsibility for all of those things is just moved to the API user, so you have to implement a lot of stuff yourself. And a good example of that is synchronization. Because imagine that you schedule 2 operations to execute on the GPU, and one operation produces, let's say, like 3 outputs, and the other one uses one of those outputs as its input. If you run this on OpenGL, then when you run the second operation, you have the guarantee that the first one is already finished and all of the outputs are done. And in Vulkan, you have to manually tell the GPU driver that, hey, actually this next operation, it needs this one of the 3 outputs of the previous one, so this one output has to be finished before the next operation starts to execute. And you can see how that kind of gives the GPU driver a lot more information that it can potentially use for optimizations. So it can, for example, figure out that it can produce the one of the outputs first, and then kind of run the second operation in parallel with producing the other 2 outputs of the previous operation. That makes it a bit faster. So now, what's Vulkan Video? It's basically a set of extensions to the Vulkan API that expose access to the hardware decoders and encoders that your GPU has through Vulkan. And the decoding extensions were finalized 2.5 years ago, and encoding 1.5 years ago, which in the world of GPU drivers, that's a very short time. So the drivers didn't have much time to mature yet. But you can have the reasonable question of why should I use Vulkan Video if we have well-established libraries for hardware video coding? And I have an answer to that, and it's a very complicated drawing that I hope to explain to you. This drawing shows 2 video processing pipelines. One is on the top, the other one is on the bottom. The top rectangle on both of those drawings is the GPU, and it has the different parts. And the bottom one is the CPU, and in the middle sits the PCIe bus, which is the interface that the CPU and the GPU use to communicate. And you can see on the top pipeline, if my laser pointing works, yeah, that first the CPU sends the encoded input video into the hardware decoder, and then once the decoder is done, it grabs the decoded output, puts it in the renderer. Then once the renderer is done, it grabs the result and then puts it in the hardware encoder. And then once it's done, only then we receive the encoded output video on the CPU. And this means that the decoded video travels through the PCIe bus and forces the CPU and GPU to synchronize 4 separate times. And this is tens of gigabytes per minute of video for each of those times. So you can see how this is hardly optimal, right? And the bottom pipeline is much nicer in a way, because the CPU only sends the encoded input video to the GPU, then the different components of the GPU kind of exchange the results inside of the GPU, and then the CPU grabs the encoded video at the end. So there's only one synchronization point between the CPU and the GPU, and also there's not much of this travel of huge decoded images through the PCIe bus. So the bottom pipelines is basically what we want to have when we process videos on the GPU, right? And this was possible to do without Vulkan Video, but it was very finicky. And basically, if you made a solution for this, then it would only work on one platform and for one GPU vendor. So a solution that works on Linux for AMD wouldn't work on Windows for AMD, or a solution that works for AMD wouldn't work for NVIDIA, most likely. And in Vulkan Video, this is all part of the same API that all hardware vendors support. So it's a very interesting promise, and that's why we were attracted to trying Vulkan Video, even though it's very new, to achieve the possibility of making those bottom optimized pipelines. So now let's talk about the API, because it's kind of interesting. So the API for decoding in most libraries, most APIs are simple. And basically you just put the encoded video byte stream in and you receive raw frames out. I'm talking about the other libraries like NVDEC or NVEng. And Vulkan Video is not like that at all. It turns out that the whole idea behind it is that Vulkan Video only handles the parts of decoding that are computationally difficult. And for example, parsing the byte stream is not very computationally difficult, so you have to do that yourself. And that wouldn't be the end of the world in its own, because there are ready-made parsers that you can use and it's manageable. But you also have to figure out a lot of stuff from the byte stream. For example, which previous frames are necessary to decode the next frame, because often codecs would kind of tell the decoder that, hey, grab this portion of the previous frame, put it in this new place in the new frame, and this way you only have to store this part of the video once, and that makes it nice to compress. But figuring out and telling the GPU driver manually that actually when you decode this frame, store it in a special place because it might be necessary later, and then later figuring out that, hey, this is no longer needed definitely and we can free up this slot. You would think that this would be easy to figure out, since this is one of the main responsibilities of the video codec. It is surprisingly difficult to figure this stuff out. For those of you who know the specifications or standards for AVC or H.264, you basically have to implement the majority of the 8.2 subsection of the standard, which is very involved, complicated, strangely complex. Now let's talk about encoding. Encoding is fundamentally simpler than encoding, and when we're talking about designing an encoder, because when you have a decoder, you kind of expect it to be able to decode any video you throw at it, right? No matter what produced it, you hope that it will decode anything. And with the encoder, you can kind of pick a feature set and say that we only support this, because in the end, for the encoder, you only care about two things. First of all, that it compresses the video well, And second, that it produces standard compliant byte streams that can be decoded by any decoder. So we can kind of limit the scope of the encoder by, for example, not including legacy features like byte streams that support very old CRT TVs, which are built into a lot of major codecs. It's still a lot to implement by hand. So we decided to make a library that the idea was that it would kind of expose this interface of the nice interface of just putting the byte stream in and getting raw frames out, but also allow you to make those GPU-only video processing pipelines that are very optimized. And the library is called VK Video. It's open source. H.264 decoding fully works, and we're right now ironing out the last kinks in the H.264 encoder. And I expect probably later in the year we'll be working on adding support for newer products like H.265 or AV1. So now, what were the pain points when I was designing and writing this library? First of all, it's a lot of reading of standards. I think 1/3 of development time was just me sitting and reading a huge book about H.264, which is complicated and boring and yeah, not very interesting, honestly. And the other third of development time was spending finding bugs in GPU drivers because the specification is very new. The drivers haven't had the time to mature yet, so they're quite buggy, especially in the case of one company specifically. But maybe you can figure out which one it is on your own. And the bugs in drivers, some of them are quite easy to find. For example, I had the driver just segfault on me. And think about this, like you try to decode the video and your GPU driver segfaults. That's an amazing experience, really recommend it. It turned out that I was passing the driver a C-style array, so a pointer and a length. And I wanted to pass an empty array, so I gave it a null pointer and the length of 0, and the driver just dereferenced that pointer. I don't know for what reason. I don't know what it does with the data. It knows there's nothing there. But some of the bugs can be a lot more difficult to track because they can manifest as just artifacts on the produced video. So you end up spending 8 hours looking at a close-up of Big Buck Bunny's arm, which kind of jiggles as it moves, and it shouldn't be doing that. And then from that, you have to figure out whether this was my not understanding the spec correctly, or me understanding the spec correctly but having a bug in my implementation, or whether this is a bug in a GPU driver, which then sometimes you have to reverse engineer, but don't tell NVIDIA that I do that. And yeah, then even when you find the root cause, it can be really difficult to fix it because sometimes I had a problem where I was passing again a list of something to the driver, and excuse me, the specification didn't specify the order the list should be in, so you understand that the list can be in any order, and on AMD the list indeed can be in any order, but the NVIDIA driver expects the list to be in a very, very specific order, which isn't documented anywhere, and I don't know how anybody is supposed to find which order this is. I just guessed 20 times, and one of the guesses turned out to be correct. So was it worth it? Yeah, I guess it was. This is a result of a benchmark. The benchmark was that we take 4 input videos, arrange them in a grid, and make basically one video with the 4 inputs in a grid. The output was always 1080p 30 FPS. On the x-axis, you can see the resolutions of the input videos, and on the y-axis is how many simultaneous live compositions I can run on my desktop computer with a beefy GPU. And the green bar is FFmpeg with just full software decoding and encoding. The orange bar is using Vulkan video, but doing the 4 times copy through the CPU. And the blue one is having the optimized pipeline. So you can see there is about 1.5 to 2x improvement in throughput, which is quite nice. So what are the conclusions? First of all, Vulkan video is a cool technology. I think it's worth to pay attention to it, and maybe the results will even improve in the future once the drivers have the time to mature. Maybe it will not be such a pain to use. And also, I hope more vendors start supporting it, so maybe we can have one standardized interface for all hardware encoding and decoding, which currently we don't really have. The other thing is try VK Video. It's free, it's open source. You can look it up at crates.io, which is the Rust package repository. And third, try Smelter. You can do that at smelter.dev. It's a really nice high-level sort of abstractions on top of those highly optimized GPU pipelines. And yeah, I guess that's it for the talk. Wow. When I was benchmarking this presentation and rehearsing it, I never got below 20 minutes, and now I see that I did it in 16. So we have a lot of time for questions, I guess.
So I have a question about what you do in between encoding and decoding. Are there nice Vulkan APIs for like doing the blend of the video streams? Is that easy to use or is it difficult?
I'd say it's rather easy to use. We started using a GPU rendering. One of the main reasons, even before we did Vulkan Video, was that the abstractions for processing images on GPUs are very nice. Because you write things that are called shaders, which are basically like tiny programs that are run on your GPU. And the abstraction is very nice because basically, conceptually, you're treated as you're writing a function that calculates the color of a single pixel. It's a very natural way to transform and process images because you basically write the code that works on each pixel in the image in order to process it, and it's really quite enjoyable, if I may say so myself.
And does that work well across platforms, or do you see the same kind of differences between the GPUs?
Once you have the bugs in the drivers figured out, it works everywhere I've tested.
Thank you.
Yeah, I had a question about the performance metrics. Number one, you said that you were comparing against the CPU. So how many? What was the power of your machine in terms of CPU when you were testing it? And on top of that, I was curious about the latency, like how long it took to encode and decode. Yeah.
Sure. I went back to the benchmarks, but my presentation is no longer on the screen. Yeah, so the parameters of the machine that the benchmark was done on is that it has the GPU is the 7900 XTX from AMD, and the CPU is the Ryzen 5800X, I think. So it's quite, the GPU is quite more beefy than the CPU, but it's rather top of the line from like 2 generations ago or so.
How many cores was that process?
16.
16, okay.
Yeah. And what was the other part of the question? Because I forgot.
Just the latency, if you noticed.
The latency.
Did you measure that at all?
Yeah. I did measure the latency, and it turns out to be, this was quite surprising, but it turned out to be almost exactly the same no matter what you do, which of these 3 processes you do.
Okay, thank you.
First of all, thanks for your presentation. Very, very interesting stuff. I wanted to ask you more about the process of going through and familiarizing yourself with Vulkan Video, because I've sort of followed in similar footsteps. And pretty much the only resources that I had access to at the time was Tony Zlatinsky's VK Video Samples repo from NVIDIA, and the Vulkan and the video coding API documentation. And that's pretty much all that I saw exist at the time. And at every single step of the journey of actually getting video to encode, there were problems and things that are difficult to find answers to. So do you have any other secret resources that you had access to when you were
No.
going through this?
No, no. And Tony Zlatinsky's Vulkan video samples is not very helpful because it's written in an arcane form of C++, which I unfortunately do not understand. Yeah, I just did it from spec. I just read the specification and nothing else. I mean, I knew how to like render stuff using Vulkan beforehand.
Good stuff. Good work.
Thank you.
Any other questions? If not, let's finish up with the big round of applause for Jerzy.